and welcome to this third and the last of three-part aquaculture innovation webinars organized by IPI, Aquaculture Innovation Center, Innovation Norway, and the Trendlines. My name is Per Christer Lund from Innovation Norway here in Singapore, and it's my pleasure to introduce you to the sequence of the presentations items here in this Aquaculture Innovation Webinar 3. We hope that you will be able to gain some insights from the speakers during the keynote sessions and the two following sessions on the key trends in sustainable aquaculture in Singapore, Norway, Israel, and globally. Over the last two other aquaculture innovation webinars, 1 and 2, we addressed a number of exciting innovations in the aquaculture industry, such as breeding culture, husbandry, waste management, cold chain logistics, etc. Today, we will address two topics. The first is recirculatory aquaculture systems, or RAS as it's called, and also next generation aqua farming technologies that can be applied to challenging locations. I just want to give a few house rules before we start. All attendees will be muted during the sessions. So if any of you out there has any questions during the presentations, type them into the Q&A panel at the bottom of your Zoom window. If there is time, we'll bring them up. We also hope that some of the questions can be answered by the presenters in written during this session. At least we will follow up with the questions. So feel free to answer Q&As. And finally, the presentation slides will be downloadable after completion of a post-webinar survey, which we will email you after the event. So let's get on to the webinar. I'd like to give the word first to an introductory remark to Mr. Pål Arne Kastman, who is Director of Innovation Norway here in Singapore. Pål, take the podium, please.
Thank you very much, Per Christer. Can you see this?
Yes, we can.
Perfect. So, ladies and gentlemen, I'm very pleased to open this third installment of our series on aquaculture innovation, and I'd like to start by extending a special thanks to our partners, the IPI, the Aquaculture Innovation Center here in Singapore, as well as Trendlines of Israel. In this third installment, we will explore the frontiers of aquaculture systems. And underpinning all innovation in aquaculture is the issue of sustainability. Consumers are becoming more aware of sustainability issues, and so it's important for the competitiveness of companies and for production processes and the positioning of products to incorporate sustainability as a core feature. And in this introduction, I will share how this transition to sustainable future aquaculture systems looks like from an Innovation Norway's point of view. Demand-driven innovation is a valuable principle when developing new technologies and products. The Global Sustainability Development Goals are a global call to action and an aggregated demand agreed on by all UN member countries. And naturally, if we are to reach these goals, industry plays an important role. But also the global goals also indicate a global demand, which in turn represents substantial opportunities for companies with relevant technologies. And what we've seen is that the Norwegian seafood industry and the suppliers of ocean-based technologies and services are determined to be part of the solutions to the world market that the world market is demanding. A more sustainable food production system, essentially. And the sustainability goals have made it easier to understand and relate to the concept of sustainability. And now we see that many companies are using them as a point of departure in the work on sustainable development. And the seafood sector plays a direct role or indirectly in several of these goals. The most obvious is number 2, 3, and 14, but also 1, 6, 8, and 12. There is a need for more sustainable food production systems, both at land and at sea. And for developing such food systems, there is a need for holistic approach, enabling technologies like digitalization, artificial intelligence, biotechnology, and material technology will all have a major impact in this development. And how would we organize the production and utilization of bioresources if we started from scratch today? Not necessarily the same way that we do it today. We need to think more about resource management and find new sources for feed and vaccines. We need to think whole value chains in order to optimize the utilization of the resources and minimize waste. We need to think circularity, how the materials can be used and reused and recycled. We need to learn from other sectors and think crossovers. Now, Innovation Norway, we are a government funding agency with 700 employees, and we have offices placed in 19 counties in Norway and 29 countries abroad. The total budget is about 1.3 billion Singapore dollars, and our financial services cover both grants and loans, as well as competence building programs and the cluster program. Today, we have altogether 44 active clusters in Norway funded by us, covering a wide selection of verticals, including several on aquaculture. In the figure in the bottom right corner, you can see the financing given to various verticals, and the elevated right or the bright blue piece is in fact not a vertical, but the additional funding we were given last year by the government to assist companies affected by the COVID-19 pandemic. The largest vertical, however, is marine, which received a total of 400 million Singapore dollars in support last year. And this constituted approximately 32% of our total budget, bar the rescue package. And as you can see from the numbers, the marine sector, mainly the seafood sector, is one of our largest customer groups. The numbers also show that the marine sector is investing in considerable amounts of money in innovation and development, since they have to contribute with 50 to 75% of the project cost themselves. We do evaluate all projects by these three dimensions of sustainability. Of course, the companies need to, in the first place, fulfill general requirements related to corporate social responsibility. And what we see are projects and new business working on more environmentally friendly material, recycling and reuse of material on and offshore in the seafood industry. And here I would like to mention that several Norwegian companies and projects are working on plastic waste and marine litter in general, cleaning, collection, and recycling. We see projects that focus on less waste and a valorization of side streams. So basically adopting a more circular economic approach where biological waste is utilized for fish oil and other types of byproducts rather than being incinerated. In the bottom right corner, for instance, we see Fjell Technology Group's facility for processing organic waste into fish oil and pellets. We see projects focusing on cleaning water, and we see projects that aim to change sludge for aquaculture to fertilizer. And we see projects focusing on cooling and transport, as well as projects focusing on fish health, pharmacology, and sustainable breeding. Now, we are looking forward to working with partners abroad to develop these technologies and opportunities further, adapted to local conditions relevant to the region. Okay, I'm conscious of the time and would like to give the word back to Per Kristian to take us through the rest of the program. So please, Per Kristian.
Thank you very much, Pål Arne, for giving us the basis and the Norwegian engagement in this very important area. I'd like to continue with a Norwegian speaker. We have two great panelists for a short discussion. The first speaker is Dr. Hans van Hoort Bjelland. I'm sure if I pronounced the middle name correct there, Hans. But you're a research director of the research institution SINTEF Ocean of Norway, and you are going to introduce us a bit on challenges and breakthrough for large-scale aquaculture systems. So Hans, could you start your presentation, please?
I can. Hello, everyone. I'm excited to be here. The usual question is, do you see my presentation? There.
We see it now, yes, please. Go
ahead. So thank you for the invite to come talk about this at this webinar. I'm just going to give a brief overview of some of the breakthroughs and some of the movements in the salmon industry, but also look at how that can absolutely be applicable and relevant also for other species and other regions. As Per Christer said, I'm a research director of aquaculture in SINTEF Ocean, which is a part of SINTEF, Scandinavia's largest independent research organization. So just a few words about ourselves. We conduct contract research, from fundamental research to very applied. In doing so, we utilize our laboratories, both large scale and small scale. We work towards innovation and new ventures. And of course, for us as all, and increasingly much so, sustainable development is key to our work here. And we also see that our competence and insight into the technological and societal changes is important also in this social debate and politics. So in SINTEF Ocean, we span from all ocean industries, where we see that aquaculture is becoming very much a very significant part of this. And we see that also the other areas of ocean industries come very much into contact with aquaculture. What we see in terms of aquaculture is that the recent years has been a very special period, with a rare rate of innovation in Norway. And we also see a significant international potential in this. Many of you might have seen some extreme pictures of new concepts coming up, and they're not only on the drawing board, but they're actually towed and installed and utilized already along the coast. Of these that you see here on the right, whereas we also see a move towards utilizing the more sheltered areas in the coast in other ways, both on land and at sea. And I often use this to illustrate that while we have open flexible cages that are still a significant part of the production both in Norway and elsewhere, we see that there is a lot of innovations happening both in RAS and semi-closed systems, as well as sheltered submergible cage designs, more rigid large cage designs. But I would also like to stress initially that conventional salmon farming and also utilization of the same type of technology for other species is already a large-scale industry. So these are just some numbers to give an insight into what kind of volume that we're talking about. Because this is Ratan 1 and 2 outside of where I'm sitting at the moment in Trondheim in the middle of Norway. One of these cages contain 1,000 tons of salmon in each cage, and that's equals 2,200 cows, just to give an impression of this. And where you can have, for example, 16 cages in one fish farm. And of course, this has been the starting of an industry, but we're very eager to look where this goes. There are some key challenges, and there are some particular challenges when we're at sea. And I like these videos because they're not extreme at all, but still they illustrate how challenging daily operations might be on sea. And we know that human work environment is challenging. We know that the daily operations and more complex vessel operations might be challenging. In Norway, we have, and with salmon, we have an environmental concern about escaped fish. and we have diseases and parasites. Whereas we have general challenges for large-scale aquaculture production also with, for example, the feed resources, fish welfare, and our environmental footprint. So closing off, regardless of which type of production system we're looking at, we see that the increase of control through digitalization is a key to succeeding here. And this is not dependent on salmon farming as such. Very much of the technologies that we develop, and I'm sure that we'll see examples of this later today, are technologies that can be readily applied for other species, other regions, and also other types of production systems, such as on land, and we're very much developing as we speak. So looking ahead, I think that current cage designs still will be prevalent in the next 10 years. There are some significant synergies between the various production systems that have a different degree of maturation at the moment. We see also that governance and regulations has to keep up. That's a key to succeeding in this. And obviously, that's why we're here today. There is a clear potential for international collaboration. So with that, I thank you.
Thank you very much, Hans. Excellent introduction to the grandness of industrial scale aquaculture, like Norway is an example of. I'd like to call upon Dr. Richard Labouchere, who is Commercial Director of Temasek Life Sciences Laboratory in Singapore, to tell us about what the opportunities are for advanced aquaculture concepts here in Singapore. Richard, would you take the stage, please?
Sure. Can you hear me?
Yes, we can.
Well, good morning, good afternoon. Thank you for having me with you today, and thank you to the organization of this event. Sharing ideas between Norway and Singapore is, I think, a fruitful opportunity to tell you a few things about what we're doing here. I'm gonna humbly give you some thoughts and idea about what we're doing from our platform in Singapore in aquaculture. So you will see it's a presentation of our expertise and also some thoughts about this RAS technology combined with new innovation. Temasek Life Sciences Laboratory has a team in aquaculture working on different topics. I will give you just a short introduction of what we're doing. These are typically the sites where we're working, so it's really next to the tank ID, because on a daily basis, this is what we do. Working with the animals and genetic programs of sea bass and saline tilapia. We have the opportunity to work in different environments and to manage systems in brackish, seawater, and freshwater. This is also something important in local aquaculture, to have this combination of three. And we do focus on genetics, reproduction, to being able to really provide to farmers in Singapore and in Southeast Asia some solution in hatchery, husbandry, fish breeding, breeding program, and also genomic selection. And more we also digged into the nutrition and health with the support of some of our partners, including Singapore Food Agency. We have the opportunity to really explore the nutrition of sea bass and the fish we are farming in the area. So working on the processing of ingredients, on the alternative ingredients, and everything related to a proper test in commercial scale facilities. That's really important. The RAS system is really a strong focus for our group, and we do have designed such systems for a few years already. This is for sure, as I will give you some details about, a strong focus. And the collaboration with industry is also very important for us in the area. Just to mention that we recently started to work on two programs, one on vaccine for sea bass, and one on a platform for single-cell protein and algae using in aquafeed. So just to give you a short introduction of what I believe is very important to figure out about aquaculture in Singapore, is a very rapid evolution. If you look in 52, what could be called aquaculture was a kelong system with fish traps around the island, 310 of them. And then in 52, 53, the transition moved to fish farm very rapidly, because in 85, already 80 farms were registered when this kelong fish trap system was slowly disappearing. In 2008, arrived another type of system with large cage farming. To give you an idea, right now it's about 122 farming license in the country. So it moved quite fast, and it's still accelerating, because as you can see, in 2018, 2020, 2021, you have here 3 examples of the system that are now existing in Singapore, mainly based on recirculated system, but very diverse and very original in many ways. And we will have a look to some of them today. What I mean here, and I think what is important, is the equation to solve in our environment is quite complex, I think. It's really a combination of different parameters, from the land to the environment, to the human resources, for sure. The food security is a very big focus for us in Singapore, and it has to be taken into account. But all this together is a very tricky one. And to be fair, we mainly use Teflon to solve this. On a daily basis, it's really a lot of piping, a lot of fish work, a lot of pipe work. And I think it's important to also realize that the more complex we go in our innovation and in our solution, at the end of the day, it's a lot of work which may look basic, but it's super important and super necessary. What I wanted to highlight also very briefly before we have the opportunity to talk together is the opportunities. I think there are some structural opportunities for us and for partners to work here in Singapore. The first one is to have the opportunity to work in a very rapidly growing ecosystem. That's significant. I can tell you, it's now 1 year I work for this organization. So many things happen in only 1 year. It's a national priority. Food capacity and food security. So it's very convenient also, because we can see this is impactful and this is useful. There is a strong culture of fish breeding. Interestingly, the ornamental industry is a strong impact. And on the farm base, it's also important to understand that the access to Southeast Asian market and the capacity to mimic the environment of Southeast Asia is major, and it's real. We also have the opportunity to work in unique research facilities like the one you can see here, based on St. John Island, a little bit south of the country, of the city, sorry. What I also wanted to raise, and maybe it can feed our discussion after, we hold these small thoughts about what I think is right now our targets. We still need to figure out solutions to develop low-cost hardware. At this moment in the history of aquaculture, we are really gathering a lot of data, but we may need to gather more, and to gather more, we will need hardware that are able to resist different environment and at low cost. We have to work on tropical biofilter control. It's quite key because right now the initialization, the monitoring of this biofilter is still a strong concern. Detection of a flavor in our RAS system is of interest. The protection of human resource in fish farming, I think, is a key also, because we are building very complex systems, and the pressure on the operators and on the managers of these sites is getting higher and higher, and this is important to monitor. With the complexity of our system comes the responsibility to make it sustainable for social also. Definition of our sustainability, very important also. What do we call sustainable? We need to monitor the domestication of our species. We need to define the reasons of automation. Is it for comfort? Is it for cost effectiveness? That's, I think, an important point. cybersecurity in our innovative solutions is of interest also. The more we build in data management, the more we really realize how sensitive it can be, and that's of interest. And all of them, I think, in summary, should be versatile, should be adaptive to many different environments, because we are on a daily basis working in changing environment, and I think that's a key. I hope I've not been too long, and I'm really happy. I will be happy to discuss with everybody.
Thank you very much, Richard, and also Hans. We have a few questions on the Q&A, but we also have a very short time. So I think I would just ask one question, one reflection here. Hans, the Norwegian aquaculture industry is characterized by rather few species: salmon, perhaps trout, now cod is coming up. But it's also about size. You mentioned 10,000 tons in one cage, which is twice as much, as far as I understand, maybe 3 times as much as the entire fish production in Singapore, and that's only in one cage. And to you, Richard, you say that there is a high-tech focus, there's a rapid evolution, and there's a quick adaptation of state-of-the-art technologies into the Singapore space. The combination of this one is, how can we combine the sizeness of Norway and the high-tech focus from Singapore to approach the markets in Southeast Asia, which should be the real big opportunity here? How can Singapore scale up and Norway scale down, to put it this way? Maybe I'll start with Hans first.
Well, I think, and Richard touched on this too, that there is a need for low cost, flexible and robust instrumentation. And that is also a key for the salmon industry as well. So I wouldn't say that it's not like this very large cage has solved everything at all. There is still a need for developing instrumentation and that fits with the needs. And we see that very much when compared to the oil and gas industry, that the solutions developed there is too costly and not fitted to the purpose of aquaculture. So there is still a search for the right level of instrumentation and technology, and an eagerness to explore the opportunities that arise, and which has given room for many startups as well to explore this domain. And to me, this sounds like a domain that very much is an opportunity for international collaboration. I think.
Thank you. Your reflections, Richard?
Yeah, I do believe also this hardware are key, because when you think about the scale, unfortunately, there is not exactly the fjord environment in the area, so we cannot really move the solution as it is. However, there are many very large scale pond farming areas around Singapore with a kind of scale effect also. And if you want to apply some technology in this type of farming, I think it has to go through the structure of data collection that has been developed on other species applied to this type of environment. Yeah. Interestingly, the data are collected in this extensive or semi-intensive farm, but they're not always collecting the way we can analyze them afterwards and design what can be a model or what can be an algorithm, what we can call AI. It's still missing, and I'm afraid we moved very fast on data analysis, and I think we're quite ready now to analyze the data, but we will need a lot of data. Yeah.
Sounds good. Unfortunately, I mean, we could have continued this discussion for a long time. Unfortunately, we are a bit squeezed on time. Can I ask you, Richard, and you, Hans, to go to the Q&A stream, and please just reply. There's quite a few questions there, quite specific ones, if you can do that. So everybody just look at the Q&A stream as well. We will move over, continue to the first session, which is on RAS systems, recirculatory aquaculture system. It was mentioned by Hans, it was mentioned by Richard as well. But we start with the first presenter in this session, which is John Diener, who's the co-founder and CEO of Vertical Oceans of Singapore, talking about integrated multi-trophic aquaculture technology. John, could you take the stage, please?
Yes, I understand that that my presentation is not showing up quite right, so I apologize for that. I'm not sure what the technical issue there is, but good morning, good evening, good afternoon for everyone who's joining, and thank you to the moderators for inviting me to share some thoughts on the topic. And before going into the background of Vertical Oceans, just give a little bit of my own background. The idea for Vertical Oceans started back in 2016 when I was the CEO of an aquaculture, nutrition, and genetics company here in Asia, and it's something that's been incubating since then. And then I finally started Vertical Oceans full time in the middle of last year. But a lot of these ideas have been incubating in our minds for a number of years, to explain a little bit about where we are at Vertical Ocean. So we joined the IndieBio Accelerator, which is one of the leading agri-tech biotech accelerators in San Francisco earlier this year. And we've made a lot of traction on our technology and our product, as well as our overall business. And right now we're operating in a small proof of concept facility at the Marine Aquaculture Center. So Richard shared earlier some photos of that facility, and we're operating just down the way from where TLL is doing and others are doing their research, and we're really fortunate to be able to operate in that kind of environment. We started very early on with a focus on production. So we recognized that some of our technologies would take some time to fully develop, but we wanted to validate very quickly whether or not we were even within the ballpark in terms of the product. And so we've now had 4 harvests of our product out of our proof of concept facility. And with that, we're selling to 30 customers. 24 of them are direct consumer customers, and also six restaurants. And so we've got quite good validation of the market demand, and we can calibrate our product quality. When we originally started, we actually started with a goal just to improve shrimp aquaculture, and the origination of that was to look at the shrimp farming. There's a lot of pond shrimp farming around Asia, and started to ask the question about how could you use technology to make shrimp aquaculture more efficient and more sustainable. And we used, to borrow this Elon Musk term, we used a first principles approach in looking at this. So we didn't take anything for granted. And our original focus was farm out. So it was really starting with the farm and thinking about, what kind of technologies could you use to improve your feeding or improve your water quality management, et cetera. But actually, as we started to take that first principles approach, we realized that we need to start looking also consumer backwards and thinking about where is the consumer, what does the consumer need, and then how could you configure an aquaculture system around that, working back from the customer as opposed to working from the farm out. And that fundamentally shifted our thinking in ways that we really hadn't anticipated. So while we started off with the intention of improving various aspects of aquaculture, we ended up kind of reinventing it in our own way. And there's lots of different ways that you can do aquaculture for shrimp and other species, and ours is one, but it's a fairly radical rethink of a lot of elements of how to do recirculating aquaculture. Unfortunately, I can't share too many images or drawings of what our technology stack is, because we're just in the process of applying for some patents. So we've had to do a kind of simplistic artist rendering of what one of our facilities might look like. But the way we describe Vertical Oceans is a biocomputer for producing sustainable shrimp in urban aqua towers. So our business model is really to produce at the point of consumption. And it's an urban farming model. Our business model is same day farm to fork, so we harvest in the morning and deliver to the customer within that day, and we would sell direct to consumer as well as to wholesale for restaurants and retailers. Our production metrics are targeting to reach jumbo shrimp in 55 days. The genetic potential is there to achieve that. In fact, can do even better than that. And also to reach a feed conversion ratio of 1. Also, the potential is there, and those are our targets that we're working towards. We also set a goal that we wanted to have 0 chemicals, 0 antibiotics, and not produce any effluent in our system. And a big part of our technology stack is designed around that. What we ended up doing is taking elements of hardware and architectural engineering, bioengineering, and computation and software, and put them together in a new model. And a lot of the technology that we're using doesn't come from the aquaculture related industries. So for example, we're using some technology from the logistics industry. In other areas, we've actually borrowed some technology from data centers of all things. And what's interesting about our approach is that we by taking that first principles view on things, we were open-minded about any kind of technologies that could be applied to this overall system. In total, we have 83 technologies across our hardware, our software, various sensors and biology, but really it focuses on 3 technology domains. So there's the bioengineering and knowledge around that. There's the hardware engineering, and then there's computation and software. And we've mapped our technology development areas onto those 3 domains, and you can see it's really a mix of all of them. A lot of what we're using is off-the-shelf technologies, so we're not trying to reinvent dissolved oxygen sensors and things like that. So where we could use off-the-shelf technology, we have. But we had to reinvent a certain number of technologies as well. So of our technology stack, 27 of them are original and patentable technologies. We have 9 technologies and operational prototypes. As I mentioned, we've got two patents that are in process and a plan to file an additional 11. And so it's quite a comprehensive rethink of the overall approach. But there are still gaps, and we're also very clear about what we're not going to do. So we're not going to try to start a breeding program to make it work in a RAS system. We're not going to try to reinvent pumps or certain other technologies that are already well developed or being effectively worked on by others. We just chose to focus on the areas that would, when put together, make the system work in an efficient way. We've also thought a lot about the market development and scale up. And this is critical for any kind of capital intensive food production model, but it's particularly critical for recirculating aquaculture because the risks are high. And people are well aware of some of the failed recirculating aquaculture projects out there, and recirculating aquaculture is a delicate balance. And our system is designed around a staged market development and a staged scale up of our business model. So, for example, being a modular, sorry, my screen just went blank. Is everyone still there? Okay.
Yes, we are.
Can you all still hear me? Okay.
Yeah, we can hear you.
So being a modular production system, it allows us to scale up and down. So we will start off with a small scale facility, which is really the minimum efficient scale for market entry. It's a low capital expenditure beachhead. And as the market grows, we can grow with that market by scaling up to a much larger scale facility. And our reference design there is around 1,000 tons of shrimp per year. And so our model is, after we develop our technology and build a tower here in Singapore, that we would scale up to other major urban markets around the world. And because of the modularity of our system, we can actually do a lot of central source of our components and prefab elements of the build out, so that we can significantly reduce the build and commissioning time of our facilities. And then we also have a flexible commercial model, and we're talking to some potential commercial partners in various countries around the world, which which can help us execute that that rollout schedule. So, from the kind of core aquaculture technologies and husbandry, et cetera, we've also expanded our development and technology development and business development around a scale-up model as well. Just to also highlight a critical element of things is that startups and technology are a lot about people as they are about the technology. And I was fortunate to be joined by an additional co-founder, Enzo, who I think is on the call today, and a great team here in Singapore. And we're very fortunate to be part of the environment in Singapore, where I think Singapore is probably a world leader right now in vertical aquaculture, at least vertical aquaculture of tropical species. And there are some other very interesting companies that are working on different kinds of technologies, but a similar urban production model in this sector. And it's really exciting to be a part of that and to be able to interact with even some of the other speakers, and I'm sure some of the attendees in this. So with that, I will stop there.
Thank you very much, John. It was truly fascinating, especially all the various technologies that you're including for this one. And I assume that there is room for upgrading and improvement and expansion and finding new solutions as well. It plays into a bit what Hans said of the crossover of other technologies into the aquaculture. Just one quick question for myself. You're focusing on prawns and shrimps. Would fish, various kind of fish, be applicable in such a concept as well, or is prawn a much easier species to breed in this way?
Yeah, it's a great question. We get that question a lot. We actually have we use a multi-trophic aquaculture system, so we do have fish and seaweed as part of our system, but they're really there more as biofiltration than they are as a primary production. So our primary production is shrimp. We certainly will sell the fish, and the seaweed we intend to upcycle into our feed or use in other ways. Fish is certainly an option that we can look at. The reason we like shrimp is that shrimp is a unique product, and there's a lot of demand everywhere in the world, and a relatively fast grow out cycle. Yeah. And because of that, we're able to get the kind of throughputs that you need to justify the capital cost that goes into the technology stack that we're developing. So from an economic perspective, shrimp is a really interesting species, but we do intend at some point to look at how can we extend the concepts behind this platform into something that could be also used for other tropical finfish or other species potentially.
We'll hear more about the bigger fish, put it this way, in the next two presentations as well. So let's move over to Israel, actually. Modi Lalouche, you're CEO of Aquatech Fisheries Limited in Israel. And you are going to talk about aqua farming in an unlikely environment. I'm quite curious to hear your definition of unlikely environment. So Modi, I'll give the screen to you, please.
Thank you, Pearl, for inviting me to participate in this webinar. Can you see my screen?
We do. Go ahead.
Okay, so I will try and share with you in the coming 10 minutes some of our experience in running RAS in an unlikely environment, which is the Israeli desert. In the middle desert of Israel is running a RAS facility. So a few words about us first before we start and dig into our activity. So we are in a pioneer land-based industrial aquaculture in Israel. We started, I would say, 7 or 8 years ago, planning, constructing, installing systems and growing fish in the desert. You can see the map of Israel. Israel is not a very big country, but we are quite far from any aqua farming activity in Israel. So this will be one of the challenges that I will discuss about. We established a 2,000-ton industrial inland fishery in the Negev, which is the Israeli desert. We started, the plan was to raise sea bream in that facility, which didn't succeed very well because of some design issues that I will talk a little bit later. Today we moved into Barramundi, which we are raising for the last 2 years now, very successfully. And we found ourselves leading the sustainable food revolution in Israel, as we are in the desert using very small quantities of water and raising quite a big amount of fish to the Israeli market. So from our experience in the last few years, we found an opportunity to leverage our RAS experience. And in the near future, we will definitely find new paths that we can leverage our experience. So this is very short introduction of who we are. So what I will try to share with you in the coming few minutes is what is the lesson that we've learned in growing fish in mid-desert. When I prepared this presentation, I found myself pinpointing five steps to success in order to be ready or able to run RAS in the mid-desert. So first of all will be the design and plan prior to execution, evaluating your business partner's location, so because you are quite far away, so how you're gonna do business with far partners. You will have to develop your own skills and know-how in RAS, ensure critical system redundancy and support, and of course, all about sustainable and effective financing. So let's start one by one. What we found when practicing RAS, definitely in the desert, there will be very small places for mistakes. So plan prior to execute. When I'm saying plan prior to execute, one of the first thing is that we understand today must to be done is conducting a very comprehensive market research about the species, about the demands, and about the other players in the market. A very important thing is choosing a reliable and experienced technology design company. I'm afraid to say, from what we've learned in the last 7 years, there's a lot of companies today who are playing with the RAS technology, developing new ideas, and we want to make sure in the future that we are not in a way of funding R&D or funding pilots unless we want to do that. So when you are contacting or working with a technology company that brings you a solution, make sure that it's a real and working solution. So when I say working solution, is that a full pilot was conducted. A full pilot is on your species of fish, on the water that you are using, on the environment conditions, because as we understand, aqua farming, every fish has its own problems, its own issues, and if you are not using ocean water or seawater or lake water, make sure that the water that you are using is being piloted. After doing that, we understand today that a third-party expertise evaluation is very important. You want to hear a third opinion, another opinion, and challenge the design, because you won't have much time to do it when you start to do it in the real environment. Have contingency plans. We understand that things might go wrong, and they will go wrong when you're in such a environment. So have contingency plans for the worst case scenarios. And last but not least is choosing high-tier execution contractors and machines. You don't want to deal with them in real life. So make sure that what you are buying, what you are working with, is really top-tier solutions. Your partners, the ones that you're going to work with, you're going to be quite far. We are quite far today from any aqua farming, whether it's suppliers or salt and packing or advisors, even they're all very far away from where we are, from where we are working. So make sure that you understand who you are working with, and we understand that today we need to develop the right system that is working with the support teams and other partners that are working with you. One of the things that we know today, that when we go and doing something as crazy as growing fish in the middle of the desert, is to have your own know-how and skills. If you want to do things done well, do it yourself. You must be ready to address things that you did not anticipated, and you want to work them or have a solution for them. So you must learn RAS very, very deeply. This is not rocket science, but at the end of the day, you want to understand the technology, the biology, and all around RAS in-house. You want to have the solutions yourselves and understand how it's work. And you want to have a team. So we have developed a team that can build the unique solutions as we go, and as we understand the challenges that are in front of us. We have the capability of developing our own solutions. You want to get the supplier's machine training workshop, because you won't get a lot of support from the vendors, because you want very quick solutions. So you want to have all the needed technology know-how, how to deal with it. Very important is writing your own SOPs. We try to use standard operating procedures that we found. At the end of the day, you have your own understanding how things needs to be run, and we are writing, and we wrote, and we're still writing our own standard operating procedures, which are unique to the solutions that we need for our species, for our technology and operation. And very, very important is training the staff, your own staff, because you're trying to find aqua farm people, and most of them have no idea about RAS. So RAS is the combination of running aqua farming, but a lot of technology, a lot of systems, a lot of machines that you want to have solutions for them, and people that know how to deal with it. So training your own staff and having the capabilities of training your staff is very important. Recovery plan of critical systems. Systems like recycling pumps, oxygen supply system, disinfection system, the electricity, new water supply. All these things, you won't have any time to deal with long downtimes. So you must have solutions, redundancy systems for this critical systems. Last thing, you never run out of things that can go wrong. So be ready with budget for unexpected things. First of all, preparing a realistic business plan would be very important, because you don't want to be in a situation that you are building a plan that is far away from your funding persons or things that you don't have a plan or a business that you can address. When you have a contingency plan, today we are communicating our contingency plan, so we understand that if things can go wrong, and they will go wrong, we are ready with budget, and we are ready with financing our contingency plan. And being transparent, we are measuring our KPIs, we know where we are, we know where we want to get into, and we are communicating it on almost a daily basis. So this is more or less what I had to share with you, giving you some of the ideas, I think, from what we went through for the last few years and what we have learned from them. And once we are going to leverage it, how we are going to do it differently from what was done in the past.
Thank you very much, Modi. This is very interesting, and I think a lot of the learnings, experience you have should be applicable to companies that are trying to do similar things, let's say in Singapore, which we will hear from by Espen next. I just have one quick question, and by the way, thank you very much for all the nice Q&As in the Q&A stream. Just continue to enter your questions and answers. I was living in Dubai a couple of years ago, and during that year, it was the first slaughter, or the first availability of salmon farmed in a RAS system in Dubai from a company called Fish Farm. There were quite a bit of skepticism of the consumers for by eating fish that was produced in a tank in the desert. You're producing barramundi. Have you experienced any kind of skepticism from your consumers, consumer side, or are there any differentiation between, I don't know, barramundi from here or barramundi from the Negri Desert?
Well, I think that at the end of the day, the quality of your product is very important. So we are very strict with the taste and the product that goes into the market. We compare the quality of our fish, and today we are addressing restaurants and really industry that understand quality, and we give them our product, which at the beginning they had a lot of worries, because they thought about off flavors that might come from facilities as ours, and we gave them a product that had no doubt that we are dealing with the issues, and we have no problem with the quality. So at the end of the day, is if you have a good product, that the market knows how to appreciate it.
Yeah. Very good point. Thank you very much, Modi. We'll go over to the last presenter of this session, Espen Johnsen, who is the CEO of the very well-edited name Singapore RAS. Espen, can you tell us what you're planning to do here in Singapore? Modi, you have to stop sharing your screen, please, first. There we go. And Espen, you take the screen and tell us what your plans are for Singapore, please.
Yeah, thank you. I will just bring it up.
Yes, we see it now. Go ahead.
Perfect. Yeah, thank you. Yeah, good morning, afternoon, and evening to all the listeners. And also first, just many thanks to IPI and Innovation Norway for the opportunity to share this. It's been perfect to listen to both John and Modi, because it sets the scene, and I think we here are sitting just in between. and I can subscribe to all the learnings that Modi was talking to with respect to how far we are then. So given the time I have here, I'll just go through the presentation following the subject you see on the screen here. So very quickly, tying back to the very first setting the challenges that we have, which is both global, local, and then from a consumer point of view. So the global, and I think Hans already touched upon this one in the beginning. You have the global mega trends, which you can sort of summarize up in the fact that we have an impending protein shortage. Then on top of that, superimposed on the global, you have the local, which is the fact that Singapore has a very high degree of import of food. And in particular of interest for this project is of course on the seafood. And you can see around more than 100,000 tons per annum is imported every year. The biggest part of the seafood is in the fish side. And specifically of interest for us is on the salmon side. So of course there is no local production as of yet. So the 6,000 tons per annum is coming in by air freight. I'll come back to that one also. So you have the global, you have the local, and then you have the consumers who wants to have more transparency and more traceability of the food that they're eating, which is then just reinforcing the need for local production of, for instance, in this case, the salmon. And then finally, like we all touch about around the sustainability and the wish in particular stronger and stronger that the solution is also touch about the circular solution and the circular economy. So the solution, let me see that I get that on right. So the solution as we see it is around the RAS, that's why we have this talk. And just mentioning a couple of elements here that is really going into the sustainability aspect of it. I think there was also talked about the sustainability elements that Hans was talking about. So the first one is around the water consumption. You have a high degree of recirculation, so can you reduce the water production very significantly. Electricity is another major component, and in the design we are really looking at minimizing as much as possible using the fact that it sits right under the equator by adding in photovoltaic panels. We believe that we will be able to reduce the consumption by 20 to 25% by doing that. We then also need to put more into the insulation and using the heat pumps to further improve the energy consumption. The fact that we will be here, we are of course going to reduce the CO2 footprint. We are removing the interactions with the wild, taking away the fish escape by bringing it on land and in rest tanks. And with that one, you're also removing all the nutrients that goes into the environment. Being in a very controlled and calm environment, you're also lowering the mortality rate. And again, reducing the food waste, which is also very much on the top of the list as we're going forward. I talked about transparency, food origin, and history. You saw perhaps on some of the earlier nice pictures on face recognition. So at the moment, we are only talking about having much improved traceability and food origin of the whole flock or the whole generation of salmon being reared. But we also see that technology is being developed to actually go down on the individual fish. Not at all yet in the RAS, but it's being already rolled out and tested out in the offshore environment. Then on the circular side, I think it's been mentioned also before, we're building in here that the sludge will be dried and treated, and that the end product from that will be into another value chain through the fertilizer that will go into the local agriculture. And then we are further looking into what can we do with all the waste that comes out from harvesting the fish and gutting the fish and preparing a value-added process to prepare the fillet and so forth. And then to transform that waste product into actual value-added fish meal and omega-3 oil. Overall, we expect all this to improve the fish welfare, which then also give good quality. And if we look at the success cases that has been commercial bean success cases in Europe, that has given really a premium quality, which fetch a price premium also. And there are a couple of good examples for that one. I'll come back to that one perhaps just after touching on the next point, which is, well, the safety is of course very important. And we have seen some interesting movies on what the environment can be out in Mother Nature in the offshore environment. Bring it on shore and inland. Of course, you have different type of safety aspects that arises, but overall, I think it's a safer working environment for the staff. We also spent quite some time looking at what are the scaling and what is the right sizing of these facilities. And having looked at the need for test bedding and demonstrated the success, and looking at was commercially successful elsewhere, we've been looking at also other unlikely places to rear fish, like in the Swiss Alps, where you have Swiss lachs that is very successful commercially. You have Danish salmon, as well as Fredrikstad Seafood. They all started in the same sort of manner, in the order of 800 tons to 1,000 tons per annum, building up the experience, building up the competences, and then going in for an expansion process in which 2 of these companies have now taken FID and so forth. So where are we in the project? We've taken it through a stage-gated product maturation funnel. So been through the identify phase, the ask phase, and the select phase. And we are now just looking at the land acquisition and into the detailed design and into operations phase. Of course, throughout those phases, you produce a lot of documents. But the biggest important element we spent a lot of time was to build a good economic model, where you can then play around with all the parameters, unit OPEX, unit CAPEX, fixed, variable, and so forth, and do some sensitivity to see what is actually driving the economics and success of the project. We also build in a couple of timelines so that we can do, like Mori was talking about, not promising everything and deliver nothing. So we have a P50, which is an expectation case that we use for the economics. And then we have a team target, P10 case, where we try to accelerate different activities. So in building up the economic model, it was important to make sure that we are using the right data. So for all the different subsystems, we've been in contact with different suppliers. We have now the cost, 90% of the costs are covered by actual commercial bid. And so it's no longer just a project cost, but it's actually more at the budget level. And for several of these subsystems, we've then gone further developing the relationships with the supply into MOUs for 7 of these subsystems. So funding side, we were quite lucky in the sense that the Friends of the Ocean World Economic Forum, they published a finance handbook in a year ago in the second quarter 2020. We've been looking into that one, looking at what is the best financial tools to use for the different phases. So the project will be funded through grants, a combination of grants, export credit, and equity funding. And then in the early production phase, project bond. The challenge we have is what has been already touched upon a little bit, is that in the previous presentation, is that you can only scale the project so little. And that's where we ended up with a starting point of 1,000 with an expansion path to 3,000. But even then, you really need quite significant amount of CapEx in the production system. And also, perhaps even more important, is that there is quite a significant time by the time you spend the first dollar in cash out and you have the very first revenue. Then just getting towards the end, lots of engagement has been done been in contact with around 100 different commercial companies and organizations and so forth. This is just a subset, and many of you are on the call, so I appreciate a lot of the good information we have received, as well as from this the learning we have done now, had this morning also on other projects. I think that where the unique value propositions we have in the Singapore and for the Atlantic salmon is around the market. We're really focusing on the 100% on the local production to really benefit from the sustainability goals that we put ourselves, and that is fully aligned with also the country strategy and wishes to increase the local production to 30% by 2030. In everything we do, we've been looking at the sustainability and trying to much as possible to build in circular solutions. And as I said before, we have seen from other RAS projects of the same types, the 3 companies I mentioned, they've all been able to produce and successfully produce premium quality and getting a quality premium. The project, as we have defined it, and as I said before, it's very strongly supported by actual bids. It is commercially attractive, and we also have a growth plan that is equally attractive. And I think I'm not quite sure on the time, so I'll perhaps just leave it at this one. And if anybody has any wish to have some more information or want to have another discussion, please just contact me and we'll pick it up here. So with that, I'll pass it back to you, Per.
Thank you very much, Espen, and of course, good luck with your initiative here. Can I just ask you a quick question? There is actually quite a few interesting one in the Q&A as well, so look at that as well. Just a quick one. Why did you choose Singapore as the market or the case to put the RAS? You could have chosen other markets with high payment willingness, such as Japan, perhaps Korea. What about Malaysia? Cheaper land, cheaper electricity, maybe. Why Singapore?
Yeah, it's many reasons, but if you just compare to Malaysia and areas around there, this would be one of the first, at least when we started, because we've been in this work for 18 months. So when we started, there wasn't too many ventures outside Northern Europe, if you want. There were ideas, but there was not that many Atlantic salmon farmed in a tropical environment outside Europe. So we then needed to make sure that, coming back to really, it was Modi was touching about, you needed as much as possible system that you can rely on, and then build in contingency and backup system. So that was a little bit, we tested out, and we found that the Singapore probably had all the best elements to successfully get this one as a first stepping out from the North European or the Norwegian Scandinavian environment. Because what has happened over the last year, there was lots of FIDs taken out elsewhere, but still it's quite focused in Northern Europe. So it was really, as I've been seen as the best environment and the best infrastructure and security of supply of manpower, capital, water, electricity, and so forth.
Yep, thank you. Just last one. So when is the earliest you can invite me for a salmon dinner in Singapore, or with your own breed fish?
Yeah, I hope that in 3 years' time we should have the first one in.
Looking forward to that. Thank you. Thank you very much to the speaker in that session, to John Diener, to Modi Lallous, and to Espen Johnsen, talking about the land-based systems. We're moving on to the last session, which we call the next generation aqua farming technology. This will focus quite a bit on the high tech, the highest tech. But before we do that, I think we'll go back into the ocean, or actually under the ocean, with the first presenter in that session, which is Morten Lysand, who's the Chief Technology Officer at Open Ocean Farming, and you're going under the waves. So Morten, can you take the screen, please, and tell us what
Yes, thank you, Per. And thank you for inviting me to present at this webinar. Everything is okay with the...
No, you have to put it in full screen mode.
I'll try that. There you are.
There we are.
So,
go ahead.
Deep ocean farming. We are a startup company working on aqua farms that we try to, or we want to bring under the surface of the ocean. Our experience is coming from Norway, of course. We are 3 people coming from the oil and gas industry, and our previous job we worked with these concepts. So we worked in Global Maritime, which is was and is involved in these designs. These are designs that was developed during the development program licenses in Norway. So after that ended in these applications ended in 2017. We focused on a different area. We got an opportunity with a retailer in Portugal, and from the experience we had with the Norwegian big constructions going more offshore, we thought maybe there could be some other solutions to do this. And in Norway, you have the industry in its whole. You have a lot of participants, and you have the knowledge, and you have the people, and you have the logistics and everything. So it's much easier to build a large construction and put it into production in Norway than any other part in the world. So if you're going offshore in a new market, like in Portugal, it's a different story. So what we did in 2017 was to see if we can put production, this was salmon, but it can be other species as well, of course, into production in a country or a part of the world where there is no aquaculture or little aquaculture, and see if we could find a solution for that. So what we did was a pilot in Portugal. We started to build a small system, like you see on the picture, a small buoy with an umbilical to a cage, and a cage that you could pull or sink down to under the waves. So we had fish trucked down from Norway, smolt into a small RAS system, and in Aveiro, and we had this system installed 11 nautical miles off the coast of the west coast of Portugal, so into the ocean, into the Atlantic, with harsh weather and a lot of waves and a lot of weather. So we had some trouble, and we learned a lot during those 2 years. The project ended in pilot project ended in May last year, and the experience from the Portugal pilot is taken into this new design that I'm going to show you more about. And when you're going into the ocean, there is a lot of things that you haven't thought of, and the learning curve is really steep, and we had built some good experience from that project. So why submerged fish farming? There's of course some obvious reasons, and that is when it comes to salmon, there is the countries or the areas that they produce salmon is more or less populated, and you have to go on land with RAS system, or you have to go offshore or more exposed to find new areas for fish farming. And of course, you have all these underlying factors that increase population and so on, and you want to produce close to the market due to sustainability. you want to be more sustainable, and so all these factors is coming in. That's why RAS is for salmon is developing in closer to the markets, and it's possible to do. You can also improve fish welfare. For salmon, you have the lice, the parasite, which is in the top of the water column. Could go down to 20 meters. If you are below that, you can find areas where you will not have lice. In Norway, this is a huge problem, and it is a costly problem for the fish farmer. You can also optimize temperature and water quality, because you can always place your fish in the right area in the water column. So this is also something that could be optimized. And a third factor we see a lot of is to avoid coastal congestion and visual pollution. This is not so much a problem in areas where you have had fish farming for many years, but if you're going into a new area, this could be a showstopper for you. If you have tourism or other things you have to think to take care of when it comes to actually seeing the fish farm at the sea. So just by bringing the cage down, you can open new areas where it's close to tourism and where it's close to market. So when you start to see, first you have to find the right areas if you want to go offshore. So what we have done is to download all the available hindcast and forecast and metocean data. So we have a big database. So now we can go anywhere in the world with a position and see if the temperature or the salinity or the wave or the weather is a good place for offshore farming. This together with the water depth and a closed harbor is the most important factors for your success to open ocean farming. That's the 6 factors. It's sustainability is of course something you have to tick off. The thing is that when you're going into new areas for offshore fish farming or fish farming at all, is that the bar has risen quite a lot. So if you are in an area where you have had the fish farming for many years, it's they develop the sustainability, but if you're going into a new area, you have to be really high up on this scale to get the license. So this is the first thing that you really need to address and find solutions for. So this is something, just going offshore is maybe more sustainable and at least less pollution from going offshore, because there is the water currents and everything will deal with the accumulation of feces and feed if that's not eaten. Another success factor is operational autonomy. So when you're going offshore, like Hans from the video from Hans, there can be rough weather in the fjords of Norway, but when you go offshore, it's really rough. And even though you will find the forecast looking good and calm, if you go offshore, you may have long period waves that is searching too much, so you can't enter even the buoy or the cage. So you really have to go operational autonomous, and you also really have to go. You need to have a system that you don't see or you cannot touch the fish for many days, maybe weeks and even months. So you have to have a fully operated system. this is me and the buoy. When you're going out there, you can get seasick, and so you really want to be operating this from land. Of course, you have to go out to take samples. You have to go out and do maintenance on the system inside the buoy. And you have to go out and look after the system. But you really have to build into the system that it should be running for a long period of time. Without any intervention from people. Operability. What we faced as a problem in Portugal is the logistics. Of course, you have the weather and the weather window, and you need to have good control of before you go out, before you install and everything, do the metocean analysis, so you know that the system can take all the weather that is coming, and you have to look on how often you can go out. If you cannot go out and refill with feed in the buoy for 2 weeks, 3 weeks, 4 weeks, you have to have a design that can hold this amount of feed or power supply or whatever. So these metocean data and metocean analysis is really important for the design. And then the logistics, you need a good port, you need waste areas in the port, you need vessels for installations, for operations. And of course, you need the hatchery and the freshwater supply close to the port, so you don't have too much transport for smolt and fish. And you need a good logistics for maintenance. So we really early saw that maintenance on the field is something that you don't want. You don't want to use divers. You have to use divers, 5 divers every time you go out because it's offshore. Sometimes even if it's cold weather, again, if the waves are long period, the divers cannot work because they have to. There's too much motion in the ocean, and even if it's cold weather, often you couldn't enter the cage because it was too much movement. You have to bring most of it back to land to do the maintenance. So our cage is easy to connect and disconnect. So when you have had one batch inside the cage, you take the cage on land and you replace it with a newly maintained cage. So all maintenance of the cage is done onshore. And of course, you need to have a scalability into it. I think Mordy also said something about it. The scalability is important because when you in a new market, you cannot build a huge cage in China for 100, 200 million euros and place it in a new area. You have to have a system that is scalable, so that you can start with a few cages, you can start with a smaller system, and then evolve and you build up the hatchery and the port and also the experience to the people and so on, and build up from the bottom up. And then you can add on more, or you can add more systems into the production. So these are the success factors that we saw that we are working on now.
Could you round it off, Morten? Your time is one more minute.
Yeah, please. Okay. So this is the system. It's a buoy with an umbilical and a cage. The cage can be operated surfaced, so you never surface the cage to do any operations. You can take out species, you can crowd the fish, you can take out dead fish, you can do everything submerged. And that's the really important thing to look at when you're going offshore. So everything is connected to the yellow hose or the buoy, and you operate everything subsea. So actually, when you do the harvesting, when you do anything inside or with the fish, you go on top of the cage and connect to the hose, and you can operate everything remotely. That's the success factor and the most important part of the system. And of course, you can use it in existing farms to just prevent lice and toxic algae. So you don't have to use it in open ocean, but you can use it in traditional cages and inshore as well. Thank you.
Thank you very much, Morten. Excellent presentation. Your statement that this is more sustainability, environmental friendly than the land-based is probably something that is subject to discussion.
No, I didn't say that.
But anyway, that's in the Q&A session is there. You have a lot of questions there, Morten. So please,
okay.
Please enjoy. Let's go over to the next speaker, which is addressing data and AI, artificial intelligence-driven farming technologies, by Mikael Voigtman, who is a co-founder, director, and CTO of Wintershine Singapore Aquaculture Technologies PT. Mikael, please take the screen.
Great, thank you, Per. Hope everyone can see that.
We do that.
Excellent. So my name's Michael, and I'm going to talk today about our journey in fish farming and how that's evolved from farming fish to farming data. You can see here on the title, we call it Aquaculture 4.0. And you also see on this title screen a shot of one of our new farms that are coming to Singapore in a few months' time. We'll have a closer look at that a bit later. Firstly, let me quickly address why we're doing this and what the challenges are of fish farming, not just in Singapore, but I think for the global industry. Trusted food source is clear. People want, and we heard that earlier, they want production close to the point or close to the market. And dovetailing with that, of course, is sustainability. Not just for the feed and where the feed comes from, but the use of antibiotics. Both of those can be addressed by optimizing feed usage and by optimizing the conditions in which we rear the fish. For that, as we also heard previously, we have to have effective SOPs, and we need to prevent diseases before they become a problem. Environmental issues are facing us all, and as aquaculture expands, it's going to become more of a problem, especially for countries like Singapore, which don't have deep water. So we have to think about what to do with the feces, the nutrients. So my talk today will focus on RAS, which we are operating in Singapore, because we believe that's one of the best ways to concentrate at least the waste so something can be done about that. And finally, we're going to look at data. Data holds the key for everything. Without monitoring and without data, you are basically driving a car with the eyes shut. So we need data, and I want to show you the systems that we have developed and are actually using. Okay, if I can move on. Right, this is an overview of what I want to present. These are our modules. I'm going to talk today about automation and SCADA and what it looks like on our farm, and how that helps us reduce work and how to streamline processes. I'm going to talk about the image analytics that we use. Image analytics or video analytics is a tool like any other sensor, except we're using it to predict the average body weight of the fish, and I'll tell you why that's important later on. I'll touch very briefly on energy management and also the MindSphere environment in which we work. Blockchain and service support for people who adopt our technology is, of course, something for the future. And I don't think the 10 minutes would give me enough time to do justice to that. Firstly, though, a quick overview of our floating fish farm ecosystem. And of course, you can see here for those coming from industry, a few terms incorporated or normally associated with Siemens. Siemens is our technology partner in our new systems. And MindSphere is the cloud-based system that Siemens is using, where we also house our data. The Cynamics and the SCADA systems from Siemens obviously help us with the way we drive the equipment, the RAS equipment. It's a complex business, and we would prefer to have an RAS run predominantly by PLC and not have to constantly monitor and interfere. We choose to do that only when that's needed. And of course, back to my favorite, the video analytics and the artificial intelligence, using edge computing and also using cloud computing. I'm going to show you what we do in those two areas shortly. Okay, firstly, SCADA, or supervisory control. Obviously, this comes from industry and how you would run a factory. And what we like about using SCADA to run all the RAS components is that it essentially gives us control on one screen, and we're not looking at all the different sensor supplies or the sensor information inputs to try and fine-tune or adjust valves. The whole system works like a symphony. If the DO is low, the oxygen valve will automatically increase, because the oxygen and the valve that controls the water inlet are both connected to the SCADA, as well as the turbidity sensor, as well as the frequency drives for the pumps, etc., etc. So all those complexities are at least now shown in one overview screen. And with that, I can get a quick snapshot of the processes and whether they're functioning properly or whether we need to make an intervention. Of course, I can go into any single screen or any single area and simply change a value. I can also do that with an iPhone or a laptop. Obviously, I don't need to be on site. The SCADA also lets me monitor the equipment and the energy draw. This shows our actual situation where we have two generators, one in duty, one in standby. Now, both of them here are not working because it's solar driven. So this shot was obviously taken during the day. You can see, well, you might not see it, but you see lots of boxes with kilowatt readings on them. Currently, they're all showing 0. That, of course, lets me see the performance and the power draw of each of the individual RAS power drawers, a biofilter blower, a protein skimmer, or a filtration drum. And what I like about this sort of technology is it lets us also predict when equipment is going to fail, because we normally see that by an uneven or slightly heightened power draw. So as we heard also earlier, RAS is about predicting problems, and it's about having contingency plans. So we would rather know in advance when something is going to happen to our equipment. This is the dashboard view, or the management information tool that we use to run the farm from a management point of view, so we know where we are exactly in terms of our performance. And this was developed also by us together with Siemens, and it's housed in the cloud. So again, we can access that at any point in time. We don't need to be on the farm. We can drill down onto various tanks and get updated information on the total biomass in the tank, or the food conversion ratio, which of course are two of the key metrics that we need to know, the mortality rate. We see trends in total feed, of course, another key metric in fish farming. Further down, of course, you have your sales information, if you want that, by tank, by species. And at the bottom, we can see our utilities consumed, in other words, electricity, since we are an offshore or a nearshore facility and not connected to mains power. So power management and energy savings are very, very important to us. Okay, now I want to spend a little bit of time on this because I find this one of the really interesting developments that we have co-developed with Siemens, and that is actively in real time monitoring the fish population size. In other words, how do I know what my biomass is in the given tank? And how do I know how much to feed that based on the biomass that's in the tank? And how do I know how much of the resources such as feed or oxygen or fresh water need to be given to a tank? I only know that if I understand what the biomass is, and typically in fish farming, that information unfortunately comes right at the end when you harvest a complete tank. So it's a bit too late after you've harvested to go back and think, well, we should have done something differently. Maybe we should have had a bigger water flow, or maybe we should have fed more feed, etc. With this solution, what we're able to do is to run our farm in real time and then test various assumptions. Now, it's going to get a little bit technical here because I want to show how we developed that algorithm, because this is now the AI part of the presentation, to take a video camera recording and convert that to a fish weight. It's not as easy as you might think. I know several companies are trying to do that. Let's see where we are in the next slide. This is a shot from the top, obviously, in one of our tanks, and the species here is barramundi. So this is the sort of feed that I see all the time, and we see that for every tank when all the cameras will be in operation. This is currently just in one tank right now. And it's interesting, I see the fish, the swimming behavior, and things like that. Now, what I want to do is take that information and I want to try and get a biomass from that. So the steps, well, they're here on the screen. Collecting the videos is probably the easiest part, but it's what you do with the images, and firstly, how you even select the images that you're going to use for your video analytics, which is the tricky bit. Once you've done that, and of course that's the beauty of our IP and that we've developed with Siemens, we don't need to go into detail, but once we've detected a fish with a clearly visible feature, that's when the algorithm can start kicking in and basically puts virtual markers on the fish, which we can then convert into a 3D distance, because we know that it's a stereo camera, we know the distance from the camera. And once we have that, we estimate dimensions that we have pre-selected on the fish. It could be simple length, or it could be a length to a height ratio. So we call that the Euclidean distance.
One more minute, Michael, please.
And then we convert that to weight. Thank you. So here's a quick snapshot of how we do that. That's an actual picture in our fish tank. You see how the AI program identifies the fish. And we'll go on from there. What did it give us? Well, this particular tank was allowing us to predict the average weight of those fish in the different size brackets, and you can see that the average prediction and the actual measured weight are very, very good. So what that means is we can now estimate not only the total biomass of the tank, but we also get a feeling for the Gaussian distribution in the tank. And once we know that, we know whether the tank is performing or whether we want to do something with that tank. It could be an early harvest, for instance. It could be a splitting of the different sizes. It could be anything else like that. And that's something. Okay, so technology and features, obviously, of our Aquaculture 4.0 approach. We have automation, enabled to save manpower and also to be more productive. We used cloud applications for connectivity and data analytics, and we have live dashboards. We use sensors, that's a given, but there we have them all on one screen and not separate screens. We have the machine learning algorithms and video analytics to predict the weight of the biomass. And of course, later on, we can use the same camera technology to look at uneven swimming behavior, early signs of disease, etc., etc. Once again, just running through that from our digitized approach, we digitize oxygen and we have control cycles. We digitize and have control cycles for water flow, for the average fish body weight, which in turn affects the feeding programs of the automatic feeder so that we're not overfeeding. We call this resources on demand. And we see the activity levels of the fish so that we can have early warnings when disease, etc., might occur. And what does that look like? Well, this is the current farm that we have that's equipped with this technology. It's a 300-ton RAS, and if you can look closely, you'll see that it's actually floating. That's how we use innovation to make use of the limited land space in Singapore by farming on the sea, not in the sea. And of course, you see a lot of solar panels. And the far right-hand picture is a hatchery, which we also have on the same facility.
We're moving out of time now, Michael. So
Thank you very much for your time. And I'll leave it to you.
Thank you. We'll distribute the presentations later if there was something missing here, Michael, but sorry for pushing you. Okay, we're probably going to go some minutes over time, but I hope all of the audience can accept that. So let's just thank you very much, Michael. That was a great presentation. Let's move over to Vidar Onarheim, who is head of sales for Aquabyte, talking about, well, going the next steps, I guess, on AI and machine learning in aquaculture. Vidar, can you try to take up your presentation?
Absolutely. Thank you for your time. Thank you for your time, gentlemen, and thank you for the possibility to share something. Some of what I'm going to speak about today is AI in aquaculture. So some of it is similar to what Michael just presented. So hopefully it won't be too much of the same. I'll go quickly since we're short on time. So I'm just going to give you a short introduction about Aquabyte, and I'm then going to show you some of the ways we utilize AI and machine learning in fish farming. So let's just play around. Now, the guy to the left well, should I say green yellow here is our founder and CEO, Mr. Brighton Shang from US, which represents half of the company as so, because we're 50-50 based in US and Norway. In US, we are based in Silicon Valley, utilizing the tech environment there, and we're combining it with aquaculture knowledge in Norway and in Chile. We've just recently started an office in Chile as well. And the combination that we're going to use, that we're trying to put forward, is the know-how of how to make the best algorithms and the know-how of how to utilize it in aquaculture as such. Starting up with Norway, of course, because of salmon, which is a high-priced market product. And then going now, we're into UK, Russia, Chile, and we're in discussions with Australia as well. So we're kind of moving fast forward. Companies like many US companies, strongly founded by different venture capital companies from throughout the world, and it's a kind of a fast-moving train. To put that into perspective, I could say that we started in 2018, and we're now like 40 people working here. So our mission is to just well, get fish farms and fish farming more efficient with software. We strongly believe that hardware is just like a shell on the more intelligent parts of the product, and that the hardware has proven to change over time. So we focus very strongly on software. Of course, in the environment we're working on, we still need the hardware, and we're always going to need the hardware, but the hardware will change. Our main products now are focusing on sea lice counting and weight data, as I would call them, and also fish health and fish welfare products. And we're strongly going into the analysis of feed or feeding, which is, well, we could say where the money really is. We do this by putting out a stereo camera, the same as the previous speaker was talking about. What we do differently, we put it into the pen and we submerge it so it's aligned with the fish or in the feeding zone of the fish. We're processing a lot of data. So we're using a lot of images. We're using still images and not videos. And we're putting them forward to our algorithms. And out of that, we extract a lot of data for the fish farmer to improve his business. I'll just show you this picture is one example of a salmon where you could see that our algorithms has identified the different body parts of it so that we can combine this and we can find out the exact weight of it by at least 98% correctness. To give you an idea of what the AI and the deep learning really now can do is we have processed 175 million pictures of fish. And if you were to do this alone, it would take you nearly 140 years. So instead we'll do it in 1 year. I'll go forward to the products to show you how we utilize it. In Norway, we have to count sea lice by legislation from the government. Every week, you have to take out 10 fish from your pen and count it. Every week, every pen, and we got like 3,000 pens. So what we're doing now is with machine learning, we identified the sea lice and we categorize it in different sizes and we make out the report for you. What you get that way is that you get a lot better consistent numbers, so we can provide the correct data, so you can watch the trends, so you can act before it's too late, and you can also learn a lot from what's happening. I'll show you some examples here. Here we got 5 pens. 3 of them has an increased sea lice level. 2 of them is free for sea lice, practically speaking, as you can see. You can see that at this point, the 2 next pens are starting to increase. And at that point, if you knew this, you could do some actions. Now, after a while again, they have all got the same sea lice levels. So then you need to make corrective actions for all your pens. The most interesting thing you can get from the data is the average weights. We do it in the same way as the previous speaker. We got this way of doing it. So we have a lot of tests with harvesting data. We have a consistency that we guarantee 98% correctness on salmon. We are about to do the same for trout, which is rainbow trout, and we're moving on to other species as well. But what this really gives you is a tool that you can detect the live SGR as it moves from day to day. It will of course not be as accurate as 98%, but the trend over a week would be very correct. So then you can see what's happening if you have a deviation on the growth, or if you have some episodes that you need to look into. We've also added an algorithm that identifies the fish to simply not count the same fish twice. That gives us a further improvement on the accuracy of the weight of it. We can also use it for identifying subpopulations of the fish, as you can see with the red circles. Here we have a subpopulation of the pen who is a lot smaller than the average. If you know this, you can grade it, or you can sort it out in some other way. But at least if you didn't know this and you're going to harvest it, you'll be surprised. This is nearly 7 or 7.5% of the population, as in this example. We could utilize it in the same way with the different weight buckets to go to market for harvesting. If you know your weight classes, you can sell when the price is best for the weight classes you really have, and you can also get more accurate sales. I'm rounding out, but by telling you it's maybe not as easy as it looks. The pens are 160 meters in circumference. It's 50 meters deep, and you put out one camera into the pen, and we're going to estimate the average weight by just looking at it. So just as like a start here. Can you easily count the fish, number of fish? Well, or how easy is the sea lice to detect? Maybe, well, maybe not that easy, but you get it over time. So rounding up, I think that's it for me. If you got any questions, I'll be happy to answer if I can, or I'll forward it to somebody else who can. Okay, thank you for your time.
Thank you very much, Vidar, for another example of using advanced technology. And I really like, we talked about earlier about this, the crossover between different industries, and you're actually originated in Silicon Valley, coming from the AI side and the computer or the machine learning, and then you found, or your founder and yourself found aquaculture as an application area. I find that really interesting. So how well do you actually understand the market there, coming from the AI side?
Well, understand the market as the aquaculture market or the AI market?
Yeah, exactly. The aquaculture market, the task of producing organic food.
I think we know it well. Myself, I started feeding fish in 1987.
All right.
So yeah, I think we know it, and we got a lot of people in our company that originates from the industry, from different sides of the industry, both feeding and also biology. We got scientists and sorry. So we're strong on the biology competence, because that's the key to it all.
Very good. Thank you very much again, Vidar. And take a look at the Q&A. There are probably some questions for you to answer there as well. Let's move on to the last speaker of today. That's Dr. Alistair Douglas, who's a senior advisor at Innovation Ecosystems at the DSM in Singapore, talking more about precision aquaculture using sensors and data analytics. Alistair, the screen is yours.
Thank you, Bert. Can everyone see my screen?
We see it. So if you could, there it goes. Yes, perfect. Thank you.
Fantastic. All right. I'd like to thank the organisers, obviously, for the opportunity to speak today. I'm working with DSM as an advisor in innovation ecosystems, and DSM is an ingredient supplier to feed integrators, to feed manufacturers. So what is their interest in sensors and analytics, you might ask? Well, we'll come to that in a little bit. This is I'll go as fast as I can given the time limitations. But this is, if you ask someone from the West, you know, what image, you know, aquaculture conjures up, it'd be something like this, be a marine cage in an environment farming species like salmon. But if you would ask a person in Asia, probably ponds or lines in fresh and brackish water. Aquaculture has a number of challenges, of course, and sites are one of them, and we're being pushed further and further away. The competition is increasing, populations are increasing. It's bringing our farming environment closer to where we live, and obviously closer to pollutants and contaminants that can come into our systems. We also have challenges of getting staff out. You've heard from other speakers. And the cost of staff to get them out. So we're continually trying to wire up our farming operations and produce sensors to do that. Sensors to measure the physical parameters, organic contaminants, and biochemical hazards and contaminants as well as the environmental contaminations. There's a number of methods. Some are handheld machines that we use. Some obviously there's a push to move from the analytical methods from labs into the field, and sensors are developing and techniques are developing quite quickly. And this is a review actually by some A*STAR and NUS researchers on the various sensors that came out just recently in 2020. So technology adoption is partly driven by our capacities, and thankfully Moore's law is holding in that we're doubling capacity in relation to time. And the other good thing is that the cost of chips are going down relative to the price that we now get for our fish. And so technology is increasingly important in how and where we fish, farm fish. Although it is a bit of a foul workplace. This is a camera that's come up, there's some work by Oregon State University. They used UV light here. So there are ways and techniques now that we're developing to help deal with this environment. There is a number of phases in this. The sensors are in a data acquisition layer. There's also the communications layer, the storage layer, and the application layer. You know, this is just one part of it, the sensor side of it. One of the major issues that we have is, you know, fault detection and whose fault it is. Where the fault occurs within this system, the diagnosis and repair is all a challenge. I'll just move this so I can actually see what's written on the slide. There we go. Downtimes are risky, especially when we're connecting to actuators such as automatic feeders or aerators. And it's very risky when it comes down to intensive systems and super intensive systems. You need trained staff, you need you know, a backup with regards to hardware and systems and procedures. And the physical security of the site is important as well. These are very expensive pieces of equipment that can be ripped off and sold. So, and then you also have to deal with data security. So why do we do all this? Well, there we go, I've got to click. It's to get data. And we talked about data before and its importance. And Michael certainly did in his last presentation. But with data, obviously, we can improve ingredients to make better feed. We can help get better seed to farms. We can improve management. This can lead to less mortality, better growth, more sustainable, lower cost, better quality. And this can all create more demand and better incentives and profits to get more data. And, you know, this helps us achieve precision farming. But there are, you know, a number of considerations. There's the 4 V's of data. There's variety, volume, veracity, and velocity of the data. There's data relevance, standards, abundance, precision, and accuracy, and speed and latency. There's data analysis. That is kind of, at the moment, we're really sort of in this descriptive space where you can see what's happening now. But we really want to move to the predictive space, so that what's happening in the future. And then we want to move to the prescriptive analytics, where it's telling us what to do. And the actuator is actually doing it, turning on the oxygen, if you like. And there it is. This is the data is the new oil. And if you're trying to sell, you know, sensors and farm application management, you need to think about this, because there's increasingly a number of papers have shown that farmers feel that they're paying for systems to refine their algorithms and learn from their farms and their data. And so that's something that you really need to consider if you're in this game, and how you can come up with new models to share revenue, monetize the data, but share that revenue with the farmers. So where are we at actually? Well, really, with data poor. A lot of examples of you've seen on farms in RAS and those sorts of things. But really, supply chains aren't working together. They're operating in silos. You might be operating a farm, but really, you know, it goes back to the ingredients. And, you know, you might know, as an ingredient supplier, you might know the quality of your ingredient, but you don't know the quality of different ingredients that are coming together at a feed mill. You don't know how they're producing that feed, whether they're denaturing your very expensive and effective enzyme. So you don't know the quality of the feed that's going either into farms or into hatcheries. You don't know the quality of the seed that's going into these farms. You don't know the environmental impacts, how the farmer is managing that feeding. And you don't know the quality of the product. And so this is a big problem, because if all these inputs come together at a farm, if the farmer fails, we all fail, and the whole system fails, and there's a massive amount of waste. So we can't operate in silos. We need to start working with one another. And how can we do that? How do we get the data that we need to improve our practices and get closer to achieving precision farming and precision nutrition? Well, we need to get environmental system and output data from the farm, from the processor, relate that back to the input data, like I mentioned before. And given the diversity of farming systems and it being a multifactorial environment, that's a lot of data that needs to be collected. and much of it is sensitive as well. But we need to find ways, we need to create vehicles and mechanisms for collecting and sharing this data. And those that do will succeed. Those that operate on their own in silos will not succeed. I make that prediction now. We came up with the Smart Farm Initiative. I was looking at what DSM was doing with their ingredients, as I say, not knowing what's happening at the feed integrator, not knowing what's happening at the farm. People at the farm aren't aware of what they do. They don't know how good DSM's products are. So the Smart Farm Initiative was put together, and it was aimed to create an ecosystem of industry partners and startups, technology providers, organisations that collaborate to gather and interpret data needed to achieve precision farming, improve feed formulations, and precision nutrition. And the benefit, obviously, to this is that the data not only enables participants and collaborators to improve their own offerings, but it assists farmers and those input providers get the opportunity to showcase their products and services. And in so doing, they can help themselves, help the industry increase efficiencies, performance and profitability, as well as help the industry become more sustainable. Essentially, the whole supply chain working together. Now, the first trial was done with DSM. It was done with the US Soybean Export Council, USEC, a Thai feed mill. And we were looking at high soybean meal content and what were the organic loading going into the farms. We were looking at a DSM enzyme solution to reduce that so that the Vibrio, the white feces syndrome, didn't have the substrate from which to develop. And that's been quite a success. And there's a number of different companies. There were 3 technology companies involved in that. This is just the sum of those companies that were involved. The future with that, Watea Aqua, a Canadian-based company with expertise in animal nutrition, but also building together a farm management application. They're now engaged by DSM to help DSM's customers, the feed integrators, with feed formulation trials. And together with DSM, they're helping to achieve precision nutrition. And DSM and Watea Aqua, together with the feed integrators, are helping the farmers achieve precision farming because they're providing all these services. They're working together to help the farmer. The farmer is not paying for this. It's just a collaboration through the supply chain. I'd just like to finish with some of a great technology that's come out recently by Sedna Tech, just to show where things are going. I love this technology. It's an orb. It's developed and it can go with the fish through the supply chain. It's absolutely critical to monitor the quality of water coming into your system, but the quality of the water holding the fish going out of your system as well, especially if you're supplying live fish to the market. And these sorts of technologies can do that. All right, there's a long way to go. We need to collaborate and we need to find ways and mechanisms to do that. Thanks very much.
Thank you very much, Alistair. And we are 10 minutes on overtime. We should have had a longer webinar because there are so many interesting things to address. And looking at the Q&A, we had about 60 questions. So we'll try to see if we can find a way to compile that and communicate that to all the participants. We should have had more time. But anyway, thank you very much to all the presenters for a very, very interesting webinar today. We hope that all of the audience enjoyed it as much as at least I did. There will be an email sent to all of you for your feedback about this webinar, and that will open up the access to the presentations. I put the link to the YouTube videos where we are having the recordings, not only of this webinar, but also of the 2 other ones that was the previous month. So please take a look at that in your time. With that, I'd like to thank all of you, all of the presenters and all of the audience. And take care, stay healthy, and see you next time. Thank you very much.